Hello my dear students in grade 12. This is my first lesson in mechanics. Please follow me in page 50. Today we are going to talk about forces, kind of forces, and Newton's second law. Let's get started with forces. We have some types of forces. The first is the driving forces and the resistance to the motion of vehicle. When a car or any vehicle moves, there are two forces applied. The driving force, which takes the vehicle upward, and the resistance force, which take it backward. So in the vehicle we have two forces acting on the same line of action, but in different directions. The first is the driving force, and the second is the resistance force, and it is represented in the air resistance and the braking and the friction. Second type of forces are tension and thrust force. This is in case that you pull or you push something inward or outward. For example, when you have a bar like this and you pull the bar outward from both directions, there is a force, or there are two forces acting on the same line of action but inward, inside the bar itself. These two forces acting to resist the pulling forces, and they are called tension forces. They work inward. But in case that you compress the bar inward, like this case, there is also two forces acting to resist this compress. These two forces are called the thrust forces, and they are working outward to resist your compress. Resultant forces and equilibrium. If an object like this experiences two forces in two different directions, like 5 Newton, 3 Newton, but in two different directions, so the resultant force is the force which is the difference between these two forces. Because this is bigger than this, is 5 minus 3 equals 2, means the object will move to the right with a force 2 newtons. But in case that the two forces acting in the same direction, so their resultant force will be the sum of the two forces. 5 plus 3 equals 8. In case that the forces are making an angle like this, 3 and 5, so the resultant force will be in the middle, means the object will move in this direction between these two forces with certain angle close to the bigger force, and the resultant force will be less than the sum of the 3 and 8, and also in this case. In case that you have two forces with the same magnitude acting in different directions in the same line of action, so the resultant force will be the difference between them, which will be 0 because they are equal. And in such case we say that the object is in equilibrium. Equilibrium means constant, equilibrium position. So what's the resultant force? The resultant force is the summation of the forces acting on the object. Look at this observation or this note, it's very important. If an object moves with a constant speed, then the resultant force acting on it is 0. Why? Because it is not increasing its speed. Means the driving force is just equal the resistant force. But if it moves with an acceleration, that means that the driving force is higher than the resistance force, and the resultant force not equal 0. Means the driving is greater than the resistant force. This is page 1. Page 2, we are talking about Newton's second law. It states that if an object moves with an acceleration, means the driving force is higher than the resistant force. So in such case, F equals ma. F means the force or the resultant force is equal to the mass of the object times its acceleration. Relating mass and weight, what's the difference between mass and weight? The weight equals m times g, means the mass times the acceleration of the gravity. W weight, m mass, and g the acceleration of the gravity. And the acceleration of gravity is changeable according to the planet itself. Example, if an object has a mass of 1 kilogram on Earth, then its weight will be 1 times 10, because the acceleration of the gravity on Earth is 10 meter per second square. So its weight will be 10 Newton. N means Newton. This is the measurement of the weight. It's been by per Newton. And we have this exercise 3C, page 55. I have selected 2 problems, 4 and 5. It's an easy one. This number 4 is talking about what force would be an astronaut of mass 70 kilogram experience while standing on the moon. So it is asking about the weight, and the weight equals mg, and since the g, which is the gravity of the force, is 1.6, you can get this information from the top here on the top of the page. There is an indication to the g of the moon, which is 1.6. So its weight on the moon will be 112. In number 5, 2 balls the same shape and size, but with mass 1 kilogram and 3 kilograms are dropped from the same height. Which hits the ground first? Both will hit the ground on the same time. Why? The answer is not written, but if you refer to the equation of motion, do you remember this 4 equations of motion? V equal ut and so on. You will you can't notice that it's not including mass. So all of these equations are not including mass. That means that mass is not a factor on the speed, does not affect the speed. So the speed does not depend on the mass. This is for you to know. Second part of the problem, if they were dropped on the moon, what difference would there be? The only difference is they will take longer time, because the g of the moon is 1.6, but the g of the earth is 10, means they go slower. Okay, this is the first video and the first lesson, and I want you to go through this exercise 3C, and please do it and picture it and upload it to me on Google Classroom as soon as possible. Thank you.